Good afternoon to everybody on the East Coast, as well everybody on the West Coast. I guess it's still early morning. So that being said, we are having quite a week over here at JetCAD Cam. It's only Tuesday, and I'm wishing it was Friday. But nonetheless, if you are new here or you are joining us for the 100th plus time, we are JetCAD Cam over here at Next. We are JitCAD Cam, and I am none other than Fusion Phil himself, the owner and lead tech support. I think only tech support. No, we have a few other guys with tech support. Um, Here at JitCAD Cam, we are here to produce content like you guys are going to see today. Today, we are going to dive into utilizing our geometry tab inside of the turning section. Now, this is an ongoing series that we are producing over here. Every week, we are doing new content both on the mill as well as the lathe that was requested to slow things down, give you guys a much more in-depth description as well as some really unique use cases. Bogdan, great to see you out there, but nonetheless, let's go ahead and jump into things and kick this off. I'm gonna go ahead and pull up my screen share here. Now, I can't see my stats at the moment. I'm gonna see if I can pull my stats up. I don't know how many of you are out there. Assumably, Bogdan in chat. We got Not Tonight in chat also saying hi. You guys must be able to see me and hear me clearly, but let's get it going. So, the request was a while ago. If you guys have missed out, we've already done a video on creating our setups and we've done a video on tool libraries. That said, the request has been, is where do I get my part files from? Well, the easiest way to do this is to show you guys in the top level of your projects tab. Down at the bottom, you have what's called CAM samples. And with that, we are working this week with the quick release hub, which is down towards the bottom here, 2x turning quick release. This allows you to bring this file in. There will be toolpaths on there, but feel free to just right click on your setups and delete them all and pick up where we are. So let's get into this. The geometry tab of the turning environment. If you're looking for the milling version of this, guys, go ahead, jump back over to our video from yesterday, but I'm going to do this no better than the best way I can know how is we always start with face because it's one of the easiest ones to understand geometry. So I'm going to reorientate my part here real quick, and I am going to give this a tool. Nothing crazy, just a CNMT rougher. But what we're mainly looking for is our geometry tab. Now, in the lathe, the geometry tab basically controls your toolpath along the Z axis. Now, this is for specifically turning tools, not for a mill turn machine. But when you start to think in the world that we're only looking to filter or constrain our toolpath along the Z, it's going to make a lot more sense on some use cases. A good example of this right off the start is if I wanted to face my part, as you can see, the very first thing it's thinking is, well, you probably want to go to the front of your model. Now, depending on your use case, you may want to offset this. Again, a offset is going to either push that boundary forward or that boundary backwards. So as you're going to see here is if I plug in a positive number, that orange line has now extended forward. If I plug in a negative number, again, we're going deeper in the part, further in, it's now pushed it further back. The problem with that would be on this particular toolpath is we would be facing off the entire front of our part, which is why we don't recommend that you guys go in and change a bunch of stuff, which always leads me back to my rules. I know I didn't cover them this week, but we always want to work left to right, top to bottom. Fusion is going to help you guys a lot when we dive into the toolpaths later on. We've already created our setup. If we go to our turning drop down, you guys would see face, rough, finish, grooves, hard off, all built out with the concept that this is the order at which you're usually going to do things, right? Rule number 2, of course, is the fact that you should, when in doubt, okay your way out. So I'm going to go ahead and turn this back to 0. But just like that, this toolpath, like I said, is simple enough if we think in the Z-axis confinement, not X as in how far our tool starts out or how far our tool goes in, just nothing more than where do we want to be in Z. Now, to advance from this a little bit, what is going to be extremely beneficial is if we actually switch gears now and we look at a profile roughing toolpath. So I'm going to go ahead and pick up my turning profile roughing. Again, very beneficial for you guys out there if you didn't know. We're going to go ahead and go to the geometry tab right now because you're going to see a lot more options. But what I would always recommend is let's go ahead and hit that OK button so that we can at least get some lines on our part and then make some decisions from there. So going back in here, looking at our geometry, what you're going to notice is the very first option we have is called model. Now, understandable that it is saying model. However, this is actually referring to selecting edges on our part based on a chain or sketch profile in this case. So again, we can't really pick anything else based on that information. So if you were to try to do face contours, you're going to notice I can barely select anything on my part profile. It's only limiting me down to where those fillets are. But for the demonstration purposes right now, it's a more advanced technique and I wouldn't get caught up in model. This is also newer to the world of Fusion. There is a time and a place for this. It's just not here in a beginner content. So we're going to move on to the idea of our front and our back. Now, pretty straightforward. Where is the front, or in this case, what mode are we using? We want to use the mode of model front, and we are machining, or in this case, turning along the Z-axis to what would be referred to as the back location. Now, for some of you out there, you're already looking at this and you're probably wondering, well, Fusion Fill, there's, grooving or we're plunging into our part. We're not going to worry about that. We are going to worry about the fact that my toolpath doesn't go all the way to the back of my part because of the stock in my setup. So again, in this case, we're going to go ahead and edit my setup. I've double clicked that. You could also right click edit. And I'm going to adjust my stock diameter out to 275. And again, this is for demonstration purposes. Let's get squared back up here. And if I regenerate my toolpaths here, you're going to notice that this time my roughing toolpath does now go to the back of my part. This is very important because as we teach over here at Lathe CAM, we're always going to want to walk through our tabs left to right, right? So we want to make sure that our geometry in the Z-axis is defined properly. For some of you, you may be parting off this file, right? So again, we want to part this off when we're done with all of our OD turning, which means we probably want to turn this further back. The number one problem I tend to see from people is they want to go through here and they want to use an offset. There's nothing wrong with this, but if I was to say offset minus 0.150, what you're going to notice is, again, we're going to get the undercutting effect back here. We're going to get that waterfalling, right? The issue with that is if you brought in your part off tool, you're going to hit a taper and not make square contact, and it could cause your part off tool to walk. So let's start by changing a few things up here. Again, I'm going to go back into my toolpath, and I'm going to change back the offset because we can leave that as 0. There is a time and place for it again, guys, and we'll look at that. But I want you guys to look at something else. We're going to move back up to the front. You have what's called a tangential extension. One of my favorite things in Fusion is how well it's put together, that if you just wait patiently, I know a lot of you guys out there can't, I'm one of them, it will tell you the different use cases when utilizing things like tangential extension. Now, a good use case here is, let me cancel out, is when we face off our part right now, we're probably wasting a lot of cycle time trying to face something that has no actual reference to what we're making. There's not a giant flat like the backside of this flange. So is facing the first operation the most efficient? In this case, it's not. So I'm going to delete that. And now we're going to make a change to our front mode. So again, we don't want to start at model front. We want to start at stock front. But again, as you're noticing, we're going all the way down the front of the part. So just by saying starting at stock front or model front, it does change where our blue lines are on our part in Z. But again, this is a lot of wasted time down here that we could remedy this a little bit better. So what I'm going to do is we're going to make another change back. I did forget to tell you guys that in the event you guys have questions at any time, feel free to throw them in the chat window. If you're watching this at a later date as well, there's a support email as well as an info email address down below. Feel free to send us those questions. We're here to help in any way. In most cases, we answer all those questions on our free support Friday. So let's go back into this toolpath. Again, what I'm going to do is I'm going to revert this back. And if you guys make changes to stuff and you don't remember what it is, we could actually go to these three little dots and you could reset to a user default, or you could reset to a system default. If you've watched other people's videos and they told you to change stuff, I would highly recommend doing the system default, as you can see here. So we're back to model front. And this time what I want to do is I want to do a tangential extension. Well, in this case, I'm going to type in 0.2. It's a guesstimated number, guys. But we're going to go ahead and hit OK again, because what you're going to notice is tangentially, it is taking the model front and that first segment being used. Because we are on the front, the segment being used is flat. It has tangentially extended that straight out off the front of our part. Now, there's a little bit of a caveat here from our setup video that you guys have watched, hopefully, is if we had a offset from front, and let's say we're going to give it about 50 thou in material because the saw is a little old, the blade's a little dull, but I can now use that offset when we think about our tangential extension. So again, I'm going to go back into my toolpath here, go to my geometry tab, and just for safe measures, let's say I go 0.75 instead of 0.50. And just like that, we have started out in front of our part, and we've kept that minor OD there based on extending from that location. But this works both on the front and the back. So another really good use case is at the back side of our part, we could do the same type of tangential extension. So what you guys are going to see here is we're going to go back to geometry. I'm going to remove the offset, and I am going to plug in now a, 150 tangential extension. And in this case, as you can see, the back offset failed to equate because I didn't push 0. That's on me. And just like that, you now notice is we're not waterfalling back here. We are now tangentially taking that straight line and continuing all the way back past our part. Now, this is going to get a little tricky here in a minute, because this is one of the few times I'm going to shift gears, and we are going to jump back to design to make this a little bit more interesting for you guys. So we're going to go to design, and if you're following along, what I'm looking to do is I'm simply going to add a chamfer to the outside profile of this part, and I'm going to actually plug one in on the front and the back here. And I am not a metric person, so we're just going to make a 1 millimeter chamfer. And the idea is now we have a few scenarios where we can utilize that chamfer to our advantage. So again, we're going to go back to the manufacturer workspace. I am going to regenerate this toolpath. And what you're going to notice is we're waterfalling again. Well, why are we waterfalling? Well, based on our back mode, we are using the model back. That would be where this green line is referred to. That green line, the last thing done was the chamfer. So we need to remedy this. Again, this is the fun of the software, is the ability to go in and use something like a back mode of selection. And then I can pick the upper edge. Now, keep in mind, this is one of those things that the tangential extension is from that line. So whatever your chamfer width is, you may need to accommodate by adding it back in here. Now, I will also put this out there for a lot of you that you could make a pretty good educated guess as well, because the ability to simulate the part off tool and make sure you're not hitting that little hat on the back of your part. But again, just like that, I utilized a tangential offset from a selected edge, and it has just continued that past the back of my part. Now, another scenario might be is if we were going to subspindle or flip this part, we could talk about stopping that even shorter and continuing on the same kind of scenario. So again, I'm going to go back into that toolpath. We're going to look at our geometry. I'm going to change my reference for selection to here. And again, we're going to follow that up with an OK. And just like that, you guys are noticing it's just taking whatever that last segment used was and extending it off your part. Now, 150 might be way too much in this particular use case. The idea is still the same for most of you out there, is you have that ability to always manually define a location. However, most of you are using offset when you should be using tangential extension. So again, one more time to see that is, let's say we want to go to here because we're going to come up and grab onto this. And when we do the groove later, we can blend those two areas. And realistically, I only need to go past maybe 50. So now you're seeing tangential extension where that fillet is, 50 thou passed. So real quick, I am going to undo this because we need to look at a few more scenarios now. And the reason why some of you are probably questioning, why am I spending so much time in adaptive turning or adaptive clear and not adaptive clearing, profile roughing, is because when we start to look at toolpaths like profile finishing, you're going to notice the options are still the same. Again, jumping a little bit further down, you have things like turning groove, but the geometry tab almost consistently in turning always does the same thing. So let's up the ante and get a little more creative with this. I also want to take a minute. You have Adolf Flores out there and Het Pate. Guys, I appreciate the love in the comment area. So again, I'm either going to move my back location or you can undo that on your side. So as you guys are seeing, I'm going to go ahead and move that to the back, have my tangential extension to go over top of that chamfer that will blend in later or do something else with. Now, to stop it from going in to this pocket here, because we're going to groove this out, this is where, again, I'm going to go back to my geometry tab and continue down my list. I know a lot of people out there, you're probably cringing, and you've probably said this a million times, is why not jump to passes, turn off grooving? Well, again, when you get too far into the tabs, you cause your own problems because you failed to define things properly here in the geometry area. So what I'm going to do to avoid grooving in there is I'm actually going to go down to what's called groove suppression, and we're going to turn that on. And now groove suppression is kind of a weird one. And unless you see it the first time, it's a little hard to understand, but you need to select everything inside of the groove area. As you guys are seeing, as I'm going from what would be referred to in the military as a left and right lateral limit, and I've gotten everything to include my vertical walls all tied up in there. So upon doing so and hitting OK, as you guys can see, we've ripped across the top, over top of that groove. We're not going into that groove at all. And just like that, I'm also using things like tangential extension to go past my part without grooving in, as it would be referred to, or undercutting or waterfalling. So Scott out in chat, just do milling at work with Fusion, but you like learning. Scott, we appreciate it. Now you got to go convince your employer to buy a lathe, right? So as you guys are seeing, that is how groove suppression works. Again, the number one thing, and you can suppress multiple groupings of grooves, just so you guys know, but you do need to take it from the left all the way to the right, because in the event you failed to select all faces, as you can see here, I am now diving down in there to come up and touch that face tilt. So again, a good way to think about the groove suppression is you're more or less telling the software, do not machine said surface, right? So we need to make sure that we are picking all of those surfaces. So if we were to shift gears here a little bit, let's say we wanted to pivot into grooving out this area. So again, I can go back to my turning toolpaths, and from here you guys could go into your finishing. We do have the option to do groove roughing and finishing separate or grooving all together. Well, I'm going to jump down to turning groove in this case. But as you can see, we could go ahead and pull a groove tool. I do have one selected. I failed to show you guys. I am also pulling my tools from the default Fusion library. Make sure that you right click, turn all libraries on, and then you can pick your OD grooving tools. So from here, I'm going to pick that turning groove tool. Again, rule number 2 is when in doubt, OK your way out. So let's go ahead and hit OK. And then let's take a look at what is wrong with our toolpath. So as you guys can see right now, it is trying to do everything on our part. So let's go back and use rule number 1, which is left to right, top to bottom. So again, I go to geometry. We're going to skip model. From here, we're going to actually change our front location. So I'm going to do a selection, and I'm going to use this very first edge here. And then I'm going to change my back to a selection, which is going to be this guy back here. So again, we can go ahead and hit OK. And now you can notice I've limited in Z where that toolpath is going to go. However, we are starting that grooving at a very, very far out diameter. Now, again, this is one of those things that you could have bad habits like myself before there was fancy options in Fusion, where you're thinking I can now adjust radii, which is going to be our video next week when we talk about radii. But looking at the geometry portion, again, I can come down and turn on things like rest machining. Again, I got it where I wanted it in Z, and now I'm utilizing rest machining and turning on rest machining. And just like that, it has trimmed the top of that toolpath because it knows that spun profile of when we used groove suppression to go over the top. And just like that, we've now narrowed that toolpath down even further. So again, seeing that a few more times, if you were utilizing groove roughing, your geometry tab is going to work the exact same way. So from there, we're going to go ahead and pivot a little bit more, and I'm going to drop down. Now, when we talk about single groove, a lot of people confuse this. I don't have a part here for a single groove, but the idea is the geometry has changed up to be based on a groove position. Now, I'm going to use this as a demonstration as I'm going to pick a edge. Now, it does need to be that minor diameter of your groove. And then from there, as you can see, we could move our tool in front of that line. We could move that tool behind the line. Now, some people always ask me, hey, why is it that that blue line is going straight to that line? Well, based on the information that I showed you guys in our tool library, is there is where you touched that tool off in X and tangentially in Z, there's a fancy little point out here in space, and that is where your blue line is coming from. But again, as you guys are seeing, that ability to do a single groove or a snap ring, maybe you're doing engine piston, who knows? And your groove tool is the exact same size. The selection process of geometry is more manual, however, very straightforward to define and pick those locations. So we're going to jump down a little bit further here. Let's look at a few other tool paths. We have the ability to do our turning thread. Again, I'm going to swap out to a thread tool. I do not have one in my library, but as you guys will see, as I can go to my Fusion library, there is threading tools in here. Again, OD threading. And from there, our geometry has changed once again. You're familiar with the milling portion of Fusion is threads are almost always defined by surfaces. As you can see, I could pick the face that I want to thread. And just like we've seen in our other tool paths, you do have a front and back, and there is a front mode, back mode. Now, keep in mind, I don't have a surface that shows threads, and that is why it says thread face selection, but you could also go to selected or manually override it as well. The neat thing about threading, though, is that ability to be able to quickly define a standardized thread size based on the information provided, and you can override this as well. So again, as you're working through that process, you have that ability to, again, turn off things like containment. You want that to utilize the front and the back location. Do you also want to change how far offset in front we're starting? This is a little crazy at the end of the day, so I may drop this down to something like 0.1. Do you want it to go past the back? Do you want to stop short? This is one of those use cases where utilizing offset here versus using tangential extension, that's why you don't see it, is very, very valuable when it comes to these type of features. So one thing we could be doing on this part is, let's say I want to thread that until I'm 100th thou away from a specific selected edge. So again, I'm going to go in and define it as this edge, not the surface. And as you can see, we're stopping before we get to that fillet. And as you can see, we have a pretty crazy thread pitch for that tool. That's okay. We're going to ignore this warning. That's all Fusion is telling me, is that my tool and my pitch right now do not match. But what I'm looking to show you guys is this is where using something like single groove again can be extremely beneficial and valuable. As you're seeing me select a different edge, again, there's a lot of ways to be able to define where you're going to cut. And then diving into this later, you do have the ability to adjust this even further. But that would be the idea of single groove to give you a thread relief. Now, I am going to delete the threads here. As you guys have seen, threads are more or less based on your tool as well as your thread information. But the geometry selection process is nothing more than picking the face that you want to thread. If your face is tapered for those pipe threads, it will follow the taper as well. So let's go ahead and shift gears here one more time. Again, we're going to go down to our part off. And what you guys are going to notice is when we talk about part off, our geometry has actually kind of done the opposite as to what our initial facing toolpath was, right? Our facing toolpath is relying on front, where our part off tool is relying on back. And just like that, we could be model back. Now, again, everybody has a different use case. Maybe I want to offset this 20 thou because we are going to flip the part and face the backside, because we all know how those lovely part off tools sometimes give you a terrible cut, but the rules still apply. Now, if you wanted to add in a edge break additionally, I'm going to go ahead and add in an edge break. This would allow you to chamfer as well when you go to do your part off. But one thing I will let you guys know, the problem relies on your radii more than anything. Now, this is just a touch on radii. We're going to talk about radii next week for our Turning Tuesday video. We're going to need to change our model outer radius to instead of stock, we're going to use model OD. And as you're going to see, it's now brought in that tool for our chamfer. And then from there, we would make much more adjustments. So again, I'm not going to keep that as it is. I just want to show you guys the scenario. Again, you have to adjust things, but the very important thing here is, once again, we need to utilize the geometry tab as much as possible before we get into that idea of jumping to the radii tab or even the passes tab to clean it up. So let's flip the entire world upside down when it comes to this stuff, because this is where I am, at the end of the day, going to look at now boring out my part. And the purpose of this is to show you that everything still works the same. So in this case, I am going to change my stock size before we do anything, because I'm not going to demonstrate the geometry portion of drilling. But we're going to base this part now off of a piece of tubing as if there is a clearance in the middle. And then one more thing I'm going to do, this is a pro tip for you guys out there, is to do a section analysis. And then with that section analysis, you do need an origin to work with or a flat plane. This part just happens to be in the middle of nowhere, but this plane is actually on center. And we're going to go ahead and flip that. And as you guys can see, I'm now looking inside of my part profile. Now, one thing to keep in mind is, based on my setup where my X is with tools coming through, the section analysis is always wise to be split that particular way. So let's go in and let's look at boring out the inside of this part. So again, I'm going to just do a turning profile rough. Rules still apply for doing profile finishing, but we're going to grab our ID grooving tool. Actually, not grooving. We're going to grab our boring bar. I apologize. Again, Fusion library. We're going to go down and do our boring, ID boring. And as you guys can see, there's my tool. If I use the famous technique of hitting OK, as you can see, this has automatically detected where it needs to go and where it needs to machine. And part of that, if we look at our radii, or not our radii, our geometry, we're model front to model back. However, our radii, because of our stock, is causing us to limit our toolpath because we used a piece of tubing. if we change our setup and modify our stock inner diameter, let's say it's 3/4, not 1 inch. And again, we'll have to regenerate our tool paths. What I'm looking to show you guys is that that boring tool path now is going model front to model back. Remember, we've yet to face this part off, so we can basically rinse and repeat what we did on the OD toolpaths to the ID toolpaths, right? So with that, I'm going to go to my geometry tab. Maybe we start with a 100 thou tangential extension. I would also like this to go through the back side of my part. This is where I might say stock back, or in this case, tangential extension on the back as well. So we're going to go in, we're going to go ahead and hit that with a 0.250. Every use case is different. I'm just here to show you guys where that info goes. We're not getting water falling in the back. We're not getting water falling in the front. And now we could wrap things up and possibly go as far as to even use this tool to maybe do a finishing pass and face off our part all in one shot. So again, when you guys get to using Fusion, you're going to notice there's a time and place. There's a lot of neat tricks and different ways to do things to cut down on cycle time. But let's do turning profile finish. When in doubt, we okay our way out. Now we can see that tool path starts too far in. Maybe I want to do my tangential extension, right? We're going to go 0.1 again. Let's go 0.2 on the back side. But we're not going around the front of our part. So again, this is one of those scenarios, as you guys are starting to see, is tangential extension might not be the play here. Because if I go back to that roughing and I determine that instead of a tangential extension, I would like to do a offset, you're going to notice that it has now pushed that tool out in front of my part and ran all the way up. So again, offset moves the boundary, extension extends whatever contour is being used. So again, we're going to go back in here one more time. We go to our geometry tab. I could say something possibly like rest machining, and you'll notice that it's now automatically trimmed once again itself down. Now, I want to make this very clear to a lot of you out there. Notice how I've never actually had to go to the geometry tab. I've never gone to the passes tab when dealing with getting my tool path in the proper location in Z. Now, some of you are going to ask me about these errors. I know you guys are, but that's why you have to go ahead and subscribe to this channel when next week we conquer some of these errors as you guys are going to get based on radii type of situations. So with that, I think I'm going to wrap it up, guys. What do you guys think? Let me know in chat. Let me know in the comments. Again, I can't say this enough. It's not what you guys know. It's who you know. You all know Fusion Phil over here at Lathe CAM. We are here to help you guys in any way possible. That's why we do this content. We love to give back to the community and show you guys what's going on. But I do also have to say, if you guys do feel the need, a fridge is getting a little light in the beer and lobster category. So feel free, if you want to donate to the channel, you guys don't have to. The likes and subscribes are plenty. We appreciate it. Feel free to do so. I'm going to let you guys get back to your day. I hope I see you guys tomorrow on Wednesday, where we're going to dive in probably one of my favorite subjects to get to talk about, which is adding machines to your shop, capabilities of machines. Should you put more parts in a machine? Should you put less parts in a machine? Let's look at the math behind cycle time and profitability when we talk about spindle time. As always, guys, look forward to seeing you guys back here tomorrow. And if you can't catch it tomorrow, feel free to join us live on Friday for another Free Support Friday. Have a good one.